Gary invited me because I thought it might be fun to talk about some of the early prehistoric stages of this technology. And I thought that rather than telling you war stories, it would be better for me to center that just on two of the personalities that were there, that helped create really the internet, starting with the ARPANet. Now it's, I say prehistory because time has been moving really fast. And I remember talking to Bob Kahn, who was one of the co-developers of TCP/IP with Lynn Cerf, talking about the history of all this. And he said, a radio station called because they wanted to talk about, about the ARPANet and what happened. And so we spent an hour on the air, and people asked questions. And after that, the guy from the station said it was really great that we talked about all this ARPANet stuff. And Bob said, we didn't talk about the ARPANet, we talked about the web, which is what people were all asking about. But before the web, the web was 1995 or so. Before that, there was a lot of other stuff. So the guy said, well, you have to come back. So they came back and they talked about the internet, TCP/IP and all that. And the guy said, again, it was great to know about the ARPANet. I said, we didn't talk about the ARPANet, we talked about the internet. The ARPANet was before that. The ARPANet was 1965, okay? Not 95, not 85, okay? And a lot of the things that we use today, like, a lot of basic protocols are still, based on the ARPANet structure. So I thought it might be interesting to talk about this. A couple of the people who were there at the beginning made it happen, because not just because of the history. I mean, history is interesting, but because of the lessons for us, because that technology is still moving ahead, as I'm sure you know. So ARPA, and by the way, I'm going to talk about ARPA and not DARPA. DARPA was a Defense Advanced Research Project Agency that, that denomination came later. At the beginning, it was the Advanced Research Project Agency. It was a Pentagon agency established by Eisenhower at the time of Sputnik, when there was this realization that we had fallen behind in science and in technology and in engineering, because the Russians were in space and we were not. And all the attempts to emulate what the Russians had done failed. I mean, those rockets blew up on the launch pad and so on. And they blew up because of the bureaucracy, not because of the technology. So there was a feeling that there should be an agency with no red tape. That's a big joke now, because DARPA has become this huge thing with a lot of red tape. But at the beginning, that was true. And the only reason there was an ARPANet and an internet and a web is that at the beginning, yes, people could have a vision and could quickly implement it, then there was money behind it. I want to talk about a man who's been was my mentor when I started really working on the ARPANet. His name was Paul Barron. Paul Barron had been born in Poland. His parents had fled to the US. He was a very bright, very visionary engineer, very humble. His name is hardly mentioned in connection with the web today. In preparing this presentation, I looked him up on Wikipedia, and there is just half a page on Wikipedia of mostly engineering jargon and nothing about what he really meant. He joined the RAND Corporation in 1959 and started researching advanced communications. And the RAND was funded by the Air Force, and the Air Force was worried about NORAD, about the North American Defense Network, because it was essentially a telephone network. I mean, it was a specialized series of telephone lines that linked the radar stations and the command posts and, the Pentagon and the senior staff. And it was very clear that in a nuclear war environment, a network like that could be destroyed with one bomb. I mean, essentially a central bomb. And today, AT&T still has central offices, okay? The central office is the idea that everything is controlled from one location, which was the basic architecture of all the communications networks in that era. And Paul Barron started researching how can we have a communication system that survives essentially nuclear war. And so it was a World War III type environment where as computing centers are destroyed, as communication centers are destroyed, the communication routes itself around the places that have been destroyed. Which is also true in peacetime, where hopefully most of the time you spend, not worrying about atom bombs, but you still have failures. And as we know, the phone system can fail at any time. And the question is, how do we survive that? Because we're now in an environment, and they knew that at the time, we're going to be in an environment where there's going to be a lot of computers. And Paul invented packet switching in '61 at RAND, but he didn't call it packet switching. He called it data blocks or message blocks. The idea was, obviously, we have to move to the digital domain. It's no longer analog. Okay, so forget analog communication. We're going to be digital. And in these digital messages, we're going to chop them up into blocks, and we're going to send these blocks around, and they are going to find their own address through whatever link is available. And if a particular computer is destroyed, a particular center is destroyed, they will find their route around that and be reassembled at the other end. Okay. That was a very advanced visionary concept in 1961, but that's what the RAND Corporation was in business to do. Then, if you look at the literature about the internet and the ARPANet, you see a lot of controversy, a lot of ego fights between Barron and Kleinrock, because Kleinrock said, gee, at UCLA, I wrote this paper on information flow in large communications nets, and I had the same idea. And there are a few other people who say, hey, I invented the network because I'm the one. And there's this firefight. It's all true. I mean, there wasn't just one idea coming from Paul Barron. There were several. The idea was up in the air, and several people were converging naturally on this kind of communication system. That, of course, every network today is based on packet switching. The name packet switching really came from an Englishman, Donald Davies, at the National Physical Laboratory in England, was working on the same need. Okay? So these three men were really at the inception of the concept. This was Paul Barron. When I met him, he was in 1962. He actually described a complete computer network based on packet switching, and he started publishing in the IEEE and in other places, and looking for support to go build it. The Pentagon was not in the picture at the time. I mean, the Air Force was sponsoring that work, and a few other people were knowledgeable about it. Davies was the first to use the word packet, and Kleinrock again published communications net. So you see those ideas were up in the air and they were sort of converging. But nobody had built anything. Barron said the obvious people to build this are at AT&T. So he went to AT&T and he writes in one interview that whenever somebody from AT&T came to RAND, he pulled the guy into his office and sat him down and told him about digital communication, and that didn't work. And when I discussed that with Paul, I met Paul in 1971, so after all this, and he was still very resentful about AT&T. He said those guys were idiots. I mean, they just couldn't see it. They were stuck with. They actually told him, "Look, young man," and he was young at the time. They would take a telephone and they say, "You see this thing? You pick it up. you talk into this part and you listen to that part. And that's what the telephone is. And we're a monopoly. We run all the telephones. We're not bad, you know, and we have the Bell Labs, you know, behind us, and we know everything that's true. And that drove him mad because he wasted 3 years trying to convince AT&T. Now, with the benefit of time, AT&T had some legitimate concerns. First, they didn't really understand digital communications, but I mean, they had some people who did, but as an organization, they had this monopoly. They wanted to keep this monopoly going, but they also had an engineering rule that any new thing they did had to work on the entire system. And packet switching didn't. I mean, packet switching was radically, you know, a revolution, and they couldn't swallow it. Professor Linkleiter was very instrumental and became one of the project directors at ARPA in the information processing office of ARPA. So when I started working with Paul Barron, I met Linkleiter at ARPA. He was writing about man-machine cooperation, came from MIT, and there was a man, by then ARPA had picked computer networking as their next big project after space. I mean, they had finally gotten America into space, into orbit, and they were looking for the next challenge, and they thought the next challenge is going to be computer network. So Bob Taylor was running the project in 1965, and he got the green light not to build what Paul Barron wanted. He got the green light to link together the computer facilities of the Pentagon, especially the research facilities, because the Pentagon was funding 10 or 15 projects around the country that had different computers. They were funding UCLA, they were funding SRE, they were funding MIT, they were funding Stanford. You know, all of those were academic research projects around computing and computer theory and so on. And they all had different computers. And the Pentagon thought that they were spending too much money maintaining all these different systems. And they said there's got to be a way to link all that. And that's when Paul Barron came in and said, I can do that. With packet switching, we can actually get all these different brands of computers talking to each other. So that's when, but the Pentagon thought the Defense Communications Agency should be involved. Now, Paul Barron, and they came to Paul Barron to saying you should essentially give your idea to the DCA and get and go to the DCA to build it. And Paul said no. And I think that was a turning point. He refused the funding and he refused to work with the DCA because the DCA is still a bunch of retired AT&T engineers from the previous war, you know, from World War II. And they had no idea what he was doing. So he thought it was a wrong thing, and he saw at that moment, which is the thing that distinguishes him from academics like Kleinrock or others, he saw that this was a management problem. I mean, the technology, you know, was understood by them, the basic packet technology. And they knew that's where they had to go, but the problem was a problem of management. And he refused to implement it for the Pentagon until he could recruit somebody who would be essentially the CEO for the whole thing. And that wasn't him. He thought, you know, he was the visionary, he was the basic engineer, that somebody needed to manage this thing, to manage the budgets, to harness all these facilities around the country, you know, behind the effort. And he recruited Larry Roberts. Larry Roberts was, you know, is a terrific manager. And when Barron and Roberts then went back to ARPA and said, okay, we're going to build it, and Roberts came up in 1966, at the end of 66, Roberts came up with the design. So these guys are going to build the first packet switching network with money from ARPA in big universities. And again, there is a misunderstanding here because you see many things in the newspapers about the ARPANet or the internet coming from defense research. That's true because they got money from Bob Taylor, who wanted to link all these facilities. There was a defense thrust behind it, but the people on the ARPANet were primarily not defense facilities. They were universities. It was really the best and the brightest of Stanford, MIT, UCLA, and so on. In the meantime, back at SRI over here, there was a project run by a man named Doug Engelbart. And I worked for Doug Engelbart before I worked with Paul Barron. So I've gotten to know both of these men as my mentors. Doug had never heard of the ARPANet. What he wanted to do, and he's known for the invention of, the mouse. And if you read his obituary, he died a few years ago, said that he's recognized as, when there was the 100 millionth mouse built, there was a big thing in the papers about Doug Engelbart is the guy who invented the mouse. Well, yeah, he invented the mouse, but that's not what Doug was about. And I think it's a pity that people don't realize the depth that there was, the vision again that there was behind Dr. Engelbart. Engelbart was a very bright engineer. He was a control system engineer. Came to SRI to work on control systems. But at the end of World War II, he had been fighting in the Pacific. At the end of World War II, when the war stopped, he was sitting in the sand on the beach somewhere on an island where they had just been fighting. And he thought, we can't do that again. We just bombed Japan with a nuclear bomb. How come all this technology, all this science we have can't help solve human planetary problems? So he was looking at the big picture. And he thought, I'm going to go back to civilian life, and that's what I'm going to do. So came to SRI and started thinking, how can we really interact with, we're going to need machines. There was already an idea that came from Vannevar Bush, of the meme, the personal machine that was going to help you. That concept, which is essentially the concept of the kind of machine we have now, was already there in the literature. And that really inspired Doug Engelbart to say, I want to build a machine that's going to help solve big problems for human communities. Now, one thing you need to do is, of course, to get rid of the stupid keyboard. And all of you have keyboards in front of you, and it is stupid. You shouldn't have to do that. Okay? So he invented two things. He invented the mouse. And by the way, when I joined him, everybody was laughing at us because there were 25 mice in the world. And they were all in this room at SRI. Nobody used the mouse. If you remember, in those days, there were no graphic screens like that. You had a screen that went line by line, and then, mostly IBM and stuff, and you'd enter commands and it would scroll, okay? So he didn't want that. He thought that's not natural. That's not what people do, okay? So he wanted to be able to move around the screen, okay, a graphic screen. And then he wanted to replace the keyboard. There's still a keyboard, but he replaced it with 5 keys, like the 5 strings on the guitar. Now, it was very funny when I joined SRI because there were two kinds of people in the group. There were about 25 of us, with the 25 mice. And half of them could play the guitar, so they were all using this device. I'm not musical, and I've never played a musical instrument. I absolutely couldn't use it. So I was still using the keyboard and the mouse, okay, which is what you do now. If you look at your device, you don't have a key set with 5 keys. You should. I mean, it's a lot. The people who could master that went much faster because they didn't need keyboards anymore. With 5 keys, you can do all the characters. If your fingers move fast enough, and with the mouse. Now the problem was he didn't have screens that could do that. So there were no digital screens when he started doing this. Okay? So he bought big TV sets, and this is a black and white TV set. So all of us had black and white analog TV sets. And he said that's obviously what you need, because when you read the Wall Street Journal, it's printed in black on white. Okay, it's not printed in yellow on green. Okay, it's the eye brain system works best with black and white characters. So that's what he wanted, except there was no way to get the characters there because it's a TV set. So he put character generators on the different channels of his computer, which was a Xerox computer, the 940 or such a thing. Apparently it was a great computer. By the time I joined them, they had gotten rid of it. But they put character generators on the little screen that was the output of the Xerox, and then they put a television camera in front of each channel. And then the television camera sent the characters to the TV set, right? So now he had large screens, and all the people who came to SRE were from IBM and Xerox were amazed and said, how can you have a big screen that's a graphic screen that's digital? Well, it isn't digital, it's analog, because we have this character generator with a camera in front of it. So it was all done with rubber bands and so on, but it worked. Okay. He, unfortunately, didn't write very well, so his proposals kept being rejected, except for 2 exceptional people. One was Roy Amara, who was his boss, was the vice president of SRE, who later became the president of the Institute for the Future out here in Palo Alto, still exists. And a woman at the Air Force Office of Scientific Research who just loved all that stuff and kept putting his proposal on top of the pile at the Air Force. And he got some money, but he only got money from the Air Force. Now, if you want to, some evening when you have nothing to do, get on Google and you type the mother of all demos, and you will hit the 1968 demonstration that Engelbart did in San Francisco. There was a meeting, I think it was a meeting of the American Library Association. It was a bunch of librarians who were there to talk about indexing on microcards. And he gave them a demo that is still extraordinary and of a series of things that you couldn't do today on the web. He was on the stage with this kind of device, and with a big screen, again, with a microwave link back to SRI, so from San Francisco to SRI. SRI was very good at microwaves. And he had a big television screen that the audience could see what was on his display. And he said, we think we need a way for people to easily enter text. And of course, today it's very difficult to do. There were still punch cards around in those days. A magnetic tape. So, and he started typing something. And he said, but my team is back in Menlo Park, and I know they're writing another part of this text, so maybe we should look at it. So he would split the screen, okay? And then you would see the blank part, and then you would see the text that the people in Menlo Park were typing. And he would say, well, let's open the voice channel. So he would open the voice channel so he could talk to the team in Menlo Park in real time and say, that second paragraph, can I borrow it for my part? So he would just highlight that and move it to the left, okay? Again, this is 1968, okay? And so the split screen had never been done before. He had hypertext that had never been done before. And he had this graphic thing where he could move things around. Now, then he could display the structure of the whole text as a graph, and then he could overlay the video from his team at SRI on top of the text. Now, you try to do that today, and it's not terribly easy to do, especially the overlay of video on top of digital text. So that was a high point for a long time of what Engelbart was doing. And it's still on the web as the mother of all demos, because it all worked, which was really the amazing thing. Now things collided, because when Larry Roberts said, look, we obviously cannot link all these computers. We cannot link Xerox with IBM, control data. But we can link little computers. All these little computers are going to be the same. They're all going to be PDP-11s, essentially. And then these PDP-11s from DEC are going to be IMPs, interface massive processors, that will talk to, so they can talk to IBM, they can talk to Xerox, they can talk to control data, they can talk to whatever the Air Force has. And then the communication will be among the IMPs. So but then Larry said, look, he went to all the different programs that were funded by ARPA and said, if you want me to send you a check next year, you have to be on this thing I'm going to call the ARPANet. And Engelbart said, I can't do it. I mean, I have this Xerox machine that does something special with these. Said, I don't care. You get rid of it, you get a PDP-10, you get an IMP or a site thing, and then I'm going to fund you. So when I joined SRI in 1971, and Engelbart recruited me because I had a lot of experience with database systems, and he hadn't thought about databases, but by that time, I mean, databases were becoming important. And he was going to run the Network Information Center for the ARPANet, and he wanted me to build it. So I said, I've seen your demo. I mean, how can I get this graph there? And how can I get, these graphics and all these things? And they would all say, oh, if only you'd been here 2 years ago, because we've lost all. So that's one of the lessons, that sometimes technology does a big circle back. I mean, we think of technology moving forward. I'm sure, here at LinkedIn, you see things moving forward, not back. But technology doesn't always work that way. So they had actually lost 3 years of work. They had, because to be on the ARPANet, they needed to go by the regulations and protocols of the ARPANet. And there were a number of layers, as you know, on the web today, same layers. Okay? You have the semantic layer, the hardware layer, communication layer, and so on. Those are still there. I mean, they were invented by those guys. Okay? And, we can't violate that. So, he was told to move, so he had to redesign. By the time I joined them, they were redesigning a lot of the things they had on the Xerox. They spoke of the Xerox as the great paradise that they had been forced out of. And they were rebuilding all that. The first IMP was installed at UCLA, second one at SRI. So SRI had engine number 2 on the network. It became the web. And the first message was sent. Paul Darren then co-founded the Institute for the Future, and Roy Amara became the president. And at the Institute for the Future, they went on to the next step, which was researching how people could use a network like this to communicate, not just to compute, to communicate. And then Engelbart demonstrated an online journal, which arguably could be viewed as the first social network, that it was only within the people who had access to this machine. 1972 was the watershed. Here, I only have 3 more slides. I'm okay on time?
Oh, yeah.
So things were converging. I mean, now Engelbart was there, all the other projects had been told, rewrite your code to conform to what we're going to tell you in terms of the structure of the protocols. And they all did that if they wanted money from ARPA, which at that point was a major source of funding for computer science research. So, you know, MIT, UCLA, and all the big guys, Stanford, SRE, and so on, all started writing code to be on the network. If you were not on the network, you were not in the community of computer science research. The host-to-host protocol was developed and tested. And you would think that everybody would applaud. Well, Congress didn't. Every time, by the time I joined Engelbart, there were 52 computers. So they'd gone from 2 to 52. And Larry Roberts would testify before the appropriations people in Congress, the Armed Forces appropriations, and they would say, well, doctor, you know, how many computers do you say you have? Well, we have 52 computers. They would say, well, that's not a research project anymore. I mean, we give you money to do research. We can give you money to link, you know, every computer in the world. Especially because the computer community was very antagonistic. You know, IBM and Xerox were saying, well, if you want a computer network, you can build an IBM network of computers. I mean, that's what they were selling. You know, if you were another company, you had, you know, all these, you had 200 IBM mainframes, and they were linked together with IBM equipment. Now, the Pentagon had a different problem because they wanted to link any computer with any other computer. And that's why the ARPANet was invented. But Xerox and IBM and so on saw that as a threat to their empires, and they were right. So they were also pushing Congress to stop funding this thing, which was this very strange animal. Well, I joined SRI, and with Elizabeth Feiner, who was a librarian, we started working on the first Network Information Center, because now that there was this network, people needed to know what services were available on all the different sites. For example, if you wanted to use an optimization model that ran at MIT, you had to know how do I address it, because I'm at UCLA, and I go in through the UCLA computer into the network out to MIT. You know, where is that resource and how do I use it? So we developed the first Network Information Center, which later became the Internet. We developed it in NLS, which was a very strange language. NLS stands for Online System, and don't ask me why it's called NLS. There was a demonstration in October 1972 where the concept of the ARPANet was unveiled for the press and for the public. And it was amazing because they had 24 hours to take over a big room at the Hilton and bring demonstrations from every site. So every site around the country, there were about 15 sites by then that had active research programs on the ARPANet. And they all needed to be able to demonstrate what they were doing. And that was the first time they were all in the same room. And they only had 24 hours to install the INS and the TIPS and so on to network all these computers together. So it was an amazing 48 hours. But it was really a technical miracle. And then people discovered, hey, there is this thing called computer networking. You better pay attention to it. Things moved on from there. After Paul Barron left the Institute for the Future in '73. He hired me to take over 2 projects from him, project for ARPA and project for the National Science Foundation. The National Science Foundation was interested in how can we use this new thing called computer network to link researchers together, geologists, astronomers, biologists, and so on, so that they can exchange research on different subjects. Paul left the Institute to start his entrepreneurial career, and then he started one company after the other. Cable Data, Com21, Equatorial, Matricom, Interfax, Telebit, Stratacom, all these companies went public one after the other, and he became a very, very wealthy engineer. But he was always an engineer, always, as I said, very humble. He did get the Medal of Technology from the president, but always said, I don't need one more award on my wall, you know, I want to continue building things. And when he was asked about his, you know, how he had come up with this idea of computer networks, his answer was always, look, I was one of many engineers, many scientists, and I just brought a couple of bricks to the, you know, to the edifice. And that was always his response. He was really a remarkable man. Now, there are other remarkable men came in. Vince served, but Kahn, they developed TCP/IP. But that was in the 70s. I mean, that was 10 years ago. Okay? And Kleinrock and Larry Roberts were really the people who continued the work, the computer science work behind all this. At the Institute for the Future, then, you know, inspired by Paul, who was my mentor at that point, he recruited me from Engelbart's team, and we built arguably the first social network on the ARPANet. And then we took it to commercial network. So, some lessons. This is Doug Engelbart in 15 years ago, 2000. This is Elizabeth Feiner I worked with in building the first NIC. That's a Medal of Technology that President Clinton had given Doug. There was a little party in his honor at SRI. By then he was out of SRI. SRI never really understood or supported very well what he was doing. They had moved on to other things by then. But Doug was still thinking about new structures that could eventually solve human problems. I mean, that was always the big picture for him. All the work he had done was just technical work on the way to solving the problems of the planet. Okay? And this is Paul Barron a few years ago, about 5 years ago, and we were just having lunch with a Chinese professor of communications, and Paul was still inventing new things. And I thought of him recently about the drought in California. In the 80s, there was already, you know, there were always droughts in California every few years. And Paul went to Sacramento with an idea. He said, you know, I invented, you know, packet switching. You could do the same thing for water. You could put power transistors on the sprinklers, you know, in the fields and in, you know, in the water systems throughout California. Those things cost only a few dollars, you know, and you could run them as a packet network, a radio packet network. And by then, there were already radio packet networks. First one had been built in Hawaii a long time ago. And we can control the flow of water, and he showed how they could save the water because you don't need to flood the fields all the time. You know, 80% of the water in California goes into almond fields and rice fields, so on. But you don't need to do that. And he quickly realized that that was a political problem and that he would not be heard. But he had the solution. And I've never seen that, you know, mentioned anywhere, but that solution had been proposed to the government of California, you know, a long time ago. So he was still coming up with all these ideas. Finally, okay, what does it mean for us today at, you know, at LinkedIn or at Google or at Intel? Well, we've only just started. I mean, the technology that we have today in this room, I mean, has a long way to go. The interfaces have a long way to go. Engelbart's dream, of being able to communicate easily with computers isn't realized. I mean, just look at all the wires we have hanging from this thing. So there are a lot of things that still need to be invented and funded by venture capital, marketed and gotten out. And also just a few people, even though it's become a huge industry, a few bright minds can have an enormous impact on the whole thing, just like Paul Barron and Doug Engelbart and Larry Roberts and a few others had a huge impact. The positives, I don't need to tell you, you're in one of the companies that's really building that human interaction at a professional level, human cooperation, learning, research, business, global information, resource management, all of that we know is being developed, it's being implemented. And there's a lot of things to be done, but the tools are there. There are also some negatives, big negatives. First, most other countries still don't understand. Every time I'm invited to the French consulate or something like that because some politician is coming by, they always want to know, how can we control the internet? Well, you have to tell them you can't. I mean, just, that's not, it's built so that there is no central control. So, yeah, you can forbid people from using it, but then, that's not going to work. And if you remember just last year, I think Turkey closed off access to the internet. It took 24 hours for the hackers around the world to build an alternative thing through Tor and so on, to reconnect. So people still misunderstand what the technology does. And the technology is relentlessly redefining, music, text, publishing, everything else. And banking is next, and television is dead, essentially, because they never got it. And so all those things are going to be reinvented. These people will have to reinvent their industry or die, starting with banking. In those days, we were talking to people about explaining what we were doing by saying, there's this arrow of information. If you get up in the morning, you go get the New York Times at the corner, the 25 cents you get in the New York Times. So the information is coming from, this big place in New York that runs the world, tells you what to think, and you get the newspaper and you read the newspaper. But in the future, with these computer networks we're building, you'll be able to say, I don't really want the New York Times. I want to know, and I don't want to know the weather because I already know the weather. I don't want to know the baseball scores because I don't care. What I really want to know is, the evolution of the oil market in the Far East. And I'm going to say, give me that. I'm going to go into this big network, and it's going to give me the information. So I have reversed this personal information error. Well, that was a nice idea, but it doesn't work that way. Because now there are big publishers on the network, AOL, Google, and others, that rank things that they think you should see because they've been paid to tell you that you should see those things. And it's very, very difficult to break that. You can. You can get on Google and say whatever you want, and you'll get it, but you may get it in 10,000 different irrelevant references. Okay. So that business that we were dreaming of, I'm going to have control of information, well, good luck. Yes, you can. But is it practical? No. And the control is more and more in these big publishing. It's not publishing companies anymore, it's publishing concerns who have mastered the technology of the web. And then you have security and privacy, which of course are two completely different things. opposite things. So we can have much better security, for example, if we implement a system, some countries probably are implementing, where I know everything you read, and I know when you borrow a book from the library, I get a message that you have borrowed this book by Karl Marx or by whoever. And then I can infer things, and that makes us more secure collectively because we know who the deviants are in the society. Okay? So you have privacy on one side and you have security on the other. There are some common things, and when we started our third fund, venture fund, I run 5 venture funds, so far, and I don't plan to run another one. But in our last fund, we thought security was going to be one of the areas that we were going to look for opportunities to invest, because security is such an obvious need now, increasing the need. And I'm sure you have that problem here. We've looked at over 20 companies, good companies, and we made no investment. Because in venture capital, when you look at the company, you do the due diligence, which is in part, if we implement this thing, how easy is it to break it? And every time we could break it. I mean, we could hire people who could break it. The reason is that cycles back, and that's the last thing I want to say, the cycles back to the early days of SRE and ARPA and Barron and so on. This was going to be a free resource. I mean, those were the days of the hippies, I could show you a picture from those days at SRE. You really had gone there, roller skates. And this was, information wants to be free. You remember that? I mean, your parents remember. Information wanted to be free. I mean, what would be better than free information around the world? I mean, why shouldn't I have access to your information and you to mine? That's such a simple concept. So that was very much sort of almost a religious vision within the people who were coding for the ARPANet. And there is a semantic layer, there's a hardware layer, there is no security layer. So if you send me a message, I have no way to be sure that it comes from you. Unless I call you on the phone and I say, Jimmy, did you not send me a message, about this thing? And unless you go to a very sophisticated system, and of course, sophisticated systems can be broken too. So it just costs a little bit more. So that's a real problem. And we see that now with terrorism, we see that now with Tor, we see it in a lot of the things we do, and we see it in the newspapers every day. That even big systems are being broken into, and that our privacy has been compromised. So what's really driving this industry now is the information on our behavior that we're putting unconsciously on the web all the time, so that the advertising companies and marketing companies can define how likely we are to buy this particular product within a particular time. And that level of lack of, it's not privacy, it's just general lack of privacy. Privacy has evaporated, and if you add security breach on top of that, then you have a world that I think we should be somewhat concerned with. Okay, so that's going through, a big cycle, but I thought it was interesting to center it on these personalities, especially on Paul Barron and Google, because they were really great men. Thank you.
We have some questions.
As a VC, did you ever seek to invest in companies whose goal was to try to turn the arrow of information back in the direction you prefer?
No. I mostly invested in architecture deals, invested in a company called Class Data Systems that was bought by Cisco. that optimized, it came close to that, but from a technical point of view, optimizing the routing, you know, within the internet, at the time, the internet and the web, so that you could be closer to essentially, you know, web